Hi everybody, welcome to day 2 of the preliminary review. Our focus is chapter P. We're going to look at operations on polynomials, we're going to talk about factoring, simplifying rational expressions, and then complex numbers. I'm going to try to go through some of this pretty quickly because it is review. So for this first example, operations on polynomials, I want you to perform the indicated operations and simplify to standard form. So that means highest degree to lowest degree. And I want you to pause the video and try these on your own and then check your answers. Go ahead and check your answers. Feel free to pause the video at this time. If you have questions, ask me in class. The next thing we're going to look at is remind ourselves about factoring polynomials. All right, so step 1 is we always look for the greatest common factor, or the GCF, okay? Then part 2 is we need to look at how many terms the polynomial has. If there's only 2 terms, we look at a difference of squares. Are both of the terms perfect squares, and are we subtracting? If that's the case, we factor it as a minus b, a plus b. Then there's sum or difference of cubes. So you did talk about this last year, but this is one that we always tend to forget. So perfect square for our first term, perfect cube for our first term, perfect cube for the second term, and one's a plus, one's a minus. That's the sum of 2 cubes, difference of 2 cubes, okay? And we factor it accordingly. Now, we've talked about possibly ways to remember that second factor, that a squared, either plus or minus ab plus b squared. So what I like to do is I like to kind of group it. First, I want to identify what is the cube root of each term, and I rewrite it as a, and then b, b, b. Cube root of a cubed is a, cube root of b cubed is b. And then we go ahead and we group these. So a times a, that's going to give us our first term here, a squared, okay? A times b, that's going to give us our second term, a times b. And then our third term is that b times b, okay? Now, how do we remember the signs? Well, I remember the signs as we started off as the same sign. So that first one is the same. Oops, sorry, I take that back. Let's erase that. All right, so this first one is going to be the same as what our original started with, okay? The second sign is going to be the opposite from what we started it with. And this last one is always a plus. So you're going to hear me say same, opposite, plus. Okay, so hopefully that's a review for you. And then we come to if we have a polynomial with 3 terms, and we'll use that product sum if there is a leading coefficient of 1 right here, or product sum splitting the middle if that a value is something other than 1. Okay, and again, we'll get some practice. Then finally, there's going to be 4 terms, and whenever we have 4 terms, we group it 2 and 2. Let's go ahead and get some practice now with factoring. Okay, now remember the rules. Always start with GCF and go from there. So let's go through these really quickly. I'm going to work them out. I want you to try on your own and then come back. Okay, so check your answers. This first example in A, we start with the GCF, which is this guy right here. And we are left with a polynomial with 3 terms. So we see if we can factor it by product sum, product of -6, sum of 1, and we're able to. So those 2 numbers were 3 and -2, and there's our final answer. Part B is simply 3 terms, so product sum, product of -24, sum of that b value, which is 2. Our 2 numbers are 6 and -4, so we can throw those into our factors. Part C, we only have 2 terms. We are subtracting those, and they both happen to be perfect squares. So this is a difference of squares. Square root of your first term is 2x. Square root of 49 is 7. One's a plus, one's a minus. Part D, 3 terms, so product sum, but our A value is something besides 1, so we do our split the middle. 2 numbers whose product is 3 times 24, but whose sum is negative 22. Those 2 numbers are negative 18 and negative 4. So now we split this middle term in terms of those 2 numbers. Okay, so we're kind of expanding it. And then we have 4 terms left over, so we group them. First 2 terms, second 2 terms. We look for the GCF within the first group, which is 3x. The GCF within the second group, which is negative 4. And what we should see is we have the same factor left over, and so our final answer, x minus 6, 3x minus 4. Okay, so the next topic will be simplifying rational expressions. So this is where we're multiplying or dividing, okay? And one thing we have to remember is we're thinking about factoring and canceling, okay? Factor and cancel is what you'll hear me say. Okay, now, another thing we have to think about is we're just dealing with fractions, right? And if we are dividing fractions, like in this example here, we want to change it to multiplying, okay? But we can't just change the sign without changing something else. So what do we have to do? We have to flip our sign and then take the reciprocal of this second term. That simply means flipping the numerator and the denominator. Okay, so step number 1 is we are going to do that, okay? So it should look something like this. We simply switched the numerator and denominator of that second term, and we change it to multiplication. Now we need to factor. So go ahead and factor each numerator and each denominator completely. Okay, so you should have factored similar to what I've got, okay? This first term here, y cubed minus 8, that is a difference of cubes. So we take the cube root of our first term, we take the cube root of our second term, and our sign stays the same, so y minus 2. All right, and then we do our little trick, y, 2, 2, 2, and we get our second polynomial here, y squared plus 2y plus 4. This first denominator here, y squared plus y minus 6, 3 terms, we're looking at product sum, 2 numbers whose product is negative 6, sum is 1, we get y plus 3, y minus 2. This guy here, y squared plus 3y, we can take out the GCF of y, and we're left with y plus 3. Same here, we take out the GCF of y, and we're left with y squared plus 2y plus 4. If we tried factoring this further, 2 numbers whose product is 4, whose sum is 2, it does not factor any further, so we leave it. Okay, so now we can check off the factoring portion. We've completely factored. Now our goal is to cancel and simplify everything. Okay, so we go through and we see, all right, well, I have a y minus 2 in the numerator. Do I have a y minus 2 anywhere in our denominator? Yes, we do, so we can cancel those. All right, going through my factors in the numerator, I have a y squared plus 2y plus 4. I have one of those in my denominator. I have a y in my numerator. I have a y in my denominator. I'm going to cancel those. And finally, I have a y plus 3 in my numerator and also in my denominator. So what are we left with? If everything cancels, do we have 0 or do we have 1? Hopefully, you're able to say, oh, this simplifies as 1. When everything cancels, we're left with 1. So 1 is our final answer. The next thing we are going to look at is simplifying rational expressions, but when we're adding or subtracting. So think about fractions, okay? What do we need when we're adding or subtracting fractions? Hopefully, you know that we need common denominators. So that's the key here. okay? So just like before, we still need to factor, okay? But we're not going to cancel until the very, very end when it becomes a multiplication problem, okay? So we need to be able to combine these by getting common denominators. So we want to factor the denominator first, okay? So I'm going to do that. I want you to do that as well, and we'll come back and see where we are. Okay, so hopefully you factored the denominators just like I did, all right? And now we need to figure out, well, what is the common denominator going to be? So in order to figure this out, I write down each factor of that first fraction, okay? So in this case, our common denominator I have m minus 3 and m plus 2 for my first denominator. And then in my second denominator, I only write down any new factors. So we have m plus 2, but we already wrote that down, so we don't need to worry about that. And then we have an m minus 1. So that is new. I'm going to write that. So there is what our common denominator needs to be. So what I need to look at is say, okay, in my first fraction, which piece of the denominator are we missing? Well, we're missing the m minus 1. So I need to multiply the numerator and the denominator by m minus 1. Okay? And then we look at the second piece and we say, all right, well, what part of that common denominator are we missing? And we should notice we're missing the m minus 3 here. So I'm going to multiply the numerator and the denominator by m minus 3. Okay? And so now what we need to do is we need to multiply the numerators out. Okay, so don't do any subtracting yet. We'll do that towards the end, but let's clean up these numerators. All right, so the first one we're going to do is we are going to multiply this piece right here. So m minus 1 times m minus 1. And when we do that correctly, we should get m squared minus 2m plus 1. Okay. Now I'm going to keep that denominator in its factored form. So we have the m minus 3 times m plus 2 times m minus 1. And now we're still subtracting that second piece. And when we multiply 3m minus 5 times m minus 3, we will get 3m squared minus 14m plus 15. And we keep our denominator. So m minus 3 times m plus 2 times m minus 1. Okay, so now our goal is to actually simplify. Okay, so now we just go through the motion and we combine our numerator. Our denominators are the same. Okay, so now we just combine our like terms. So what we'll get here is we're going to say, okay, we have m squared. Now remember it's minus 3m squared. So m squared minus 3m squared, that is going to get us negative 2m squared. And now we have minus 2m minus a negative 14m, so that goes to plus 14m. So that's going to take us to plus 12m. And then finally we have plus 1 minus 15, so that's going to take us to minus 14. And then we keep our entire denominator, and we have m minus 3, m plus 2, and m minus 1. What we could look at is we want to see if we can simplify this any further, and that would mean we would have to factor the numerator. If we do, we could take out that common factor of negative 2. So if I take out a negative 2, that leaves me with m squared minus 6m plus 7, all over that same denominator, m minus 3, m plus 2, m minus 1. And what we should notice is that m squared minus 6m plus 7, it doesn't factor any further. Two numbers whose product is positive 7, but sum is negative 6, it won't work. Okay, so that could be the final answer. Or we could have just left it like this piece right before it. Okay, finally, on to the last topic for today is complex numbers. Okay, so if you look at our little side note over here, complex numbers is a plus bi, that represents a complex number. A is the real number, and b is the imaginary number. So one thing we have to remember is I is equivalent to the square root of -1. All right, that allows us to take the square roots of negative. So if I is equal to the square root of -1, we also have to remember that if we were to square both sides, we would get I squared is equal to -1. So that's kind of a key piece. Whenever we see I squared, we will replace it or substitute it with -1. Okay, so we're going to go through these operations really quickly. All right, and then that'll be the day. So let's take a quick look at this first example here. All right, where we have 2 minus the square root of -18. When I see the square root of a negative, I pull that out right away, and it becomes an I. So what we really have is 2 minus I times the square root of 18. And now we just simplify the square root of 18. Biggest perfect square that goes into 18 is 9. Square root of 9 is 3. So we are left with 2 minus 3i times the square root of 2 as our final answer. Okay? In part B, where we are squaring a binomial. Remember, this is just like saying 3 plus 2i times 3 plus 2i. All right, so now we just FOIL. So when we do that, we are going to get 3 times 3, which is 9, 3 times 2i, which is 6i, another 2i times 3, so another 6i, and then finally we have 2i times 2i, so 2 times 2 is 4, I times I is I squared. So this is where we see this I squared portion, okay? So I squared is really just -1. So what I do is I cancel that out and I change the sign in front, so it's really -4. Okay, because it's saying 4 times -1. All right, and now we just gather our like terms. So we really have 9 minus 4, which is 5, and then our 6 i's we can combine to be 12 i's. So there is our final answer of 5 plus 12i. Finally, simplifying powers of I. So I need to do a quick note of my little spiel over to the side. So we're going to talk about remainders, okay? And one thing we need to note is I is simply equivalent to I. We would leave it, okay? If we get I squared, we know that that's equivalent to -1. If we have an I cubed, this is like saying I times I squared, and we know I squared is -1. So this is equal to -I. And then if I have I to the 4th, we can think of that as equivalent to I to the 0, and anything raised to the 0 power is 1. Okay, now this is just a little side note, all right, as a reference that we'll make. When we are simplifying powers of I, the approach I take is I'm going to take this power 77 and I'm going to divide it by 4. Okay, so 77 divided by 4, because what we're going to end up with is we're going to be left with either a remainder of 1, a remainder of 2, a remainder of 3, or a remainder of 4, which is equivalent to a remainder of 0. All right? So I go through and I say, all right, well, 77 divided by 4. Well, what is that? Well, 4 goes into 77 19 times with a remainder of 1. This remainder portion is the key, because this becomes the new power. All right? So I to the 77th is really equivalent to I to the first power, that new power, which was what our remainder was. All right? And if we look over here at our side notes, I to the first power, we simply leave as I. So I to the 77th is equivalent to I. All right? So when you are simplifying powers of I, you will get an answer of I, -1, -I, or 1. Those are the options. All right? If you have any questions from this video, make sure you ask those in class. Otherwise, have a great day.